Hey class, it's Math Guy Steve. All right, so this is a review for our final exam practice test in Math 1050. And so let's get to it. So this first one here says, write the set using the roster method. Pay attention to repeated elements and think about why you don't need to list the same element more than once, right? So keep that in mind. So here it says, H is a set of letters in the word Hawaii, right? So if I want to write just the letters in the word Hawaii, considering that we're not repeating anything, right? Then we'd have our fancy brackets here, okay? And the letters we have is H. Got it. We need an A, okay. We need a W, got it. Now we already have the A, so we don't have to repeat it, or we don't have to repeat that letter. And so we also need an I, and again, we don't have to repeat that I, okay. All right, question 2 says sets A and B are subsets of the universal set U, and so these sets are defined as follows, okay. So write the following sets, so find the following sets and then write your answers in roster form, or as this O with the line through, remember that's the empty set, right. And so here we say, well, not A or not B. So again, these apostrophes are complements, and so we consider them as not the word not, right. And so let's consider, okay, if I said A not, right, or A complements, then that set would be, well, the stuff that's in the universal set that's not in A. And so we'd say, okay, 2, 3, 5, again, 6 and 7 are in A. So we're saying not in A. And so 9. So there would be A prime or A not or A complement, right? And then B prime or B not or B complement. So let's consider that one, right? So B has 3 and 7. So the stuff that's in the universal set that's not in B. And so that would be what here? 2, 5, 6, and 9. Got it. And so we need A complement or B complement, or B complement, right? So A prime or B prime. And so we'd say, well, the stuff that's in, that's the stuff that's in A prime or in B prime or in both, okay? So we'd say, well, list all the stuff in A, that's 2, 3, 5, 9, and then, or the stuff that's in B. Again, we don't have to duplicate anything, right? And so 2 and 5 are already there, so 6, and then 9 is already there, so we don't have to duplicate. And so this would be A complement or B complement. The next that we have is, what about A complement and B, or the intersection, right? So this union is the word or, this intersection here is the word and, okay? And so we need A prime and in B, got it. So we said A prime was 2, 3, 5, and 9, okay? B is given, that set is given, so 3 and 7. And so we say A prime and B, we're saying the stuff that's in A complement and also in B. So it has to be in both. Okay, so that's the word and, it has to be in both. So what's in A, or what do they have in common? All they have in common is this element of 3. Okay, so A prime and B would be just the set with 3 in it. All right, number 3 says there's 12 teams make the National Football League playoffs each season, okay? This diagram shows the teams that made the playoffs in 2012 and 2013. Use the diagram to answer each question. So here, how many teams made the playoffs both years, right? So again, 2012 is this blue one here, 2013 is this green one, and they overlap in the purple. So we're saying how many teams made the playoffs in both of those years is where they overlap. So we just count how many teams are in the middle, right? So Denver, San Francisco, so 1, 2, 3, 4, 5, 6, 7. So we say 7 teams made the playoffs in both years. Part 2 says select all the playoff teams from 2012. So just 2012, right? So we'd highlight, okay, Atlanta, got it. And I'm just gonna put a check mark here. Atlanta, Houston, Washington. Luckily, they're in alphabetical order. It's easy to check. Baltimore, Minnesota here. But then also, against this whole blue circle, even the overlapping ones, right? So we're also going to highlight Denver, San Francisco, New England, Cincinnati, Indianapolis, Green Bay, and Seattle. Okay. So we just check off all the ones that are in blue part and where they overlap. Question 3 says, in what year or years did Cincinnati make the playoffs, right? And so is it just 2012 or 2013 or both, right? So where is Cincinnati? Where is Cincinnati? Well, Cincinnati, notice, is in the middle. So that'd be both, right? That's where they overlap. And so we say, yeah, in both 2012 and 2013. All right, question 4 says, in a class of 25 students, 12 were math majors, 10 were computer science majors, and 3 were dual majors in math and computer science, okay? All right, question 4 says, in a class of 25 students, 12 were math majors, 10 were computer science majors, 3 were dual majors in math and computer science, okay? So using the diagram tool to illustrate the situation, meaning to fill out this first one, we'll say, okay, well, we know 3 were in both, right? So math and computer science, we put 3 here. Then we know, okay, 12 were math majors. So now, again, that means the whole math majors circle should total to 12, right? So this is 3, then only 9 should be here, okay? Then 10 were computer science majors. So we know the whole computer science major circle should be 10. So if this is 3, then this should be 7. And then we know there's 25 students altogether. So altogether in the entire green class rectangle should total to 25. Well, this is 7 plus 3 is 10 plus 9. That's only 19 students accounted for. So we know the difference 6 would have to be outside. They weren't math majors or computer science majors. So now let's answer some questions. Here it says, how many students were majoring in math only? Well, that would be just this part here, right? So not in the math and computer science where they overlap, just this 9 here. Okay. Part 3 says how many students were not majoring in computer science. So again, we're just saying cover up the computer science circle, right? And so if we cover that up, it'll just be this 9 plus 6, so 15 total would be not computer science majors. And then part 4 here says how many students were not math or computer science majors. Again, that would be not math or computer science, would be covering up all the math and computer science circles together, right? And so 6 would be how many were not math or computer science majors. All right, question 5 here says, how many 4-letter passwords can be formed from the letters in the word inhale if each letter has to be distinct? So for this kind of problem, we kind of set up our slots here, right? So when we have 4 letters that we need to create, and it says each letter has to be distinct, meaning once I pick, okay, we have 6 letters total, then none of them are the same. And so there's 6 options for the first letter, but then everything has to be distinct. Each letter has to be distinct. And so once we use one of the letters, the next one would be, okay, well, there's 5 letters remaining available for the second slot. Then once we use those 2 letters, there's 4 letters remaining for the third slot, right? Because we can't overlap. And same thing with the fourth slot, there would be 3 left. And so then we just use our fundamental counting principle, which is multiplication. We multiply these slots. And so 6 times 5 times 4 times 3, we get 360, okay? Part 2 says how many 4-letter passwords can be formed from the letters in the word inhale if letters are allowed to be repeated, right? And so for that one, we say we still have the 4 slots. There's 6 options for the first letter, but then they can be repeated, right? And so for the second letter, there's still 6 options. For the third letter, same thing. There's still 6 options. And then for the fourth letter, still 6 options. So 6, and again, we still multiply these numbers, right? So 6 times 6 times 6 times 6, or 6 to the 4th, we get 1,296 different options. All right, question 6 here says, how many ways can 2 men and 2 women be selected for a debate tournament if there are 12 male finalists and 14 female finalists? So for this one, we're going to separate them into male and female, right? And so for the male ones, we'll say, okay, well, there's 12 of them, and we're choosing 2, right? We're choosing 2. So remember that choose button, that NCR button, right? So the NCR in our calculator. So 12 choose 2. And then for the females, we'd say, okay, that's 14 choose 2. Okay, we're choosing them. And then we're multiplying those 2. So still using our fundamental counting principle. And so those numbers end up being 12 choose 2 is 66, and then 14 choose 2 is 91. Multiplying that, we get 6,006. This one here says draw a graph to represent the map. Use vertices to represent the states and the edges to represent the common borders. And so we say, okay, well, there's 5 states here. They call them A, B, C, D, and E. So here's A and here's E. Let's put D right here then. Let's put B right here. Okay, and then C right here. And then now we say, well, which ones are they touching, right? So like A is touching B and D. That's it. Right? B is touching A, D, and C, right? So A, D, and C, and then C is touching B, D, and E. Okay, so C is touching B and D. Sorry, are touching B, so D and E is touching D and C, and so that would be our map there. All right, number 8 says 3 systems of linear equations are shown. For each system, choose the best description of its solution. If the system has exactly one solution, give its solution. So in this first one, these 2 lines are parallel lines, right? They have the same slope, but not the same y-intercept. So they're parallel lines, meaning they don't touch at all. In other words, there's no solution to the system. In part B, it says L1 and L2 are essentially the same line here, right? And so because they're the same line, there's infinitely many solutions. They're lying on top of each other. Okay, so it's infinitely many solutions, so we'd say it's infinitely many. And then this one here, they meet up at just one point here, right? So there's exactly one solution here. And so how we find that is by, well, since both of them are y equals, we can find the x coordinate of by just setting them equal to each other. So 2x minus 2 equals half x plus 1, and now solving for x. Okay, now I don't like fractions, so let's get rid of them in the first step. Multiplying by the LCD, multiplying by 2, we get 4x minus 4 equals x plus 2. Subtracting x, we get 3x minus 4 equals 2. Adding 4, we get 3x equals 6, and so x equals 2. That's the x coordinate of where they meet up. To find the y coordinate, just plug it back into any one of the equations, right? And so we know that y equals 2x minus 2, so y equals 2 times 2 minus 2, or in other words, 4 minus 2, so 2. So though it looks like they meet up at 2, 2, I wanted to make sure by setting them equal to each other. Okay, so yeah, they meet up at the point 2, 2 at just that one point. Example 9 says solve this system. Now this system has three equations and 3 variables. How we solve this system, we can use substitution or addition or graphing to solve it. The best way is to use our calculator. All right, so remember, so we put these in a matrix. We put these in matrices, right? So to get to our matrix stuff, you see above the x inverse is the matrix button. So we put a second matrix, and then we have to go edit this matrix, and then we type them in. Now this is a this would be a 3 by 4 augmented matrix, right? And so our augmented matrix would be 4, 2, negative 4, 4, right? 3, negative 4, negative 2, 26, and then negative 2, 5, 7, negative 21. Okay, so again, a 3 by 4 matrix. And our goal is to RREF, right, that matrix A. Okay, remember it's RREF, right, double R, which is row reduced echelon form. And so when we do that, we'll get an identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, and then whatever's on the other side of the augments, right, whatever's here is our solution. And of course, we know this is in X, Y, Z form since that's what our variables are written as. Okay, so here's our calculator, right? We know it's a 3 by 3 matrix. And so we start typing our numbers in. So here's our calculator. We know it's a 3 by 4 matrix. So we start typing our numbers in. So our next step is to get out of there, right? So we get second mode or second quit to get out of there. Then we go back to the matrix stuff, right? So second matrix, to get to RREF or RREF, we go to math and go all the way down, right? Remember, it's the one with the 2 R's, right? Press enter, and then now we need to put the matrix in there, right? So second matrix again, and go to name here, right? Names, name the matrix. And then press enter. And so now notice our identity matrix here, and then whatever's on this side, 4, negative 4, 1, would be our solution set. So we'd say that's where they meet up, 4, negative 4, 1. So it says graph the solution set. So how we graph this is by doing a bunch of shading. So first we consider these two lines. So let's consider just the lines 3x plus 2y equals negative 12. And then we need to graph this line. So how we graph it? Well, just find the x and y intercepts. That's the easiest way, right? So I find the x-intercept. We plug in 0 for y, so we get 3x equals negative 12, divided by 3, x equals negative 4. Let's find the y-intercept. Plug in 0 for x, so we get 2y equals negative 12, and so divided by 2y equals negative 6. So that's where it crosses the x and y axis. So it crosses the x-axis at negative 4, 0, and it crosses the y-axis at negative 6, 0. Then we put a line through it. Now, if it's an equal sign involved, then it's a solid line. This has an equal sign, so it's a solid line. Okay, if it's not, we put a dashed line. So put a line through them. And now we have to shade. So to find out how we shade, we pick a test point. Usually the best test point is the origin, 0, 0. Sometimes we can't use 0, 0 because the line goes through the origin. So we just pick another point, 1, 0, or 0, 1. So if we plug in 0, 0 into the inequality, let's see what happens, right? So we get 3 times 0 plus 2 times 0. Is that smaller than negative 12? So that's 0. Which is not smaller than negative 12, right? So 0, 0 should not be shaded, meaning we shade away from the origin, or in other words, we shade below this line. Let's call this the blue line. We shade below the blue line. Then we go to the next line, right? So we got 3x minus y is greater than or equal to 6, right? So same thing, find the x and y intercepts to plot it, right? The x-intercept, if I plug in 0 for y, we get 3x, pretend it's an equal sign, so equals 6, and so x equals 2. Okay, then we find the y-intercept by plugging in 0 for x, and so we get negative y equals 6, so y equals negative 6. So that's where it crosses the x and y axis at 2, 0. Across the y axis at negative 6, 0. Got it. Well, that point's already there, meaning we kind of can see where these two lines meet up, because they both have the y-intercept of negative 6. But now we need to know if I'm shading above this line or below this line. And how do we find that? By plugging in a test point, right? So if I have a test point, again, I could plug in 0, 0 or any other point if I needed to. So here we get 3 times 0 minus 0. Is that bigger than 6? Well, that's 0 minus 0, which is 0, which is not bigger than 6. So we know the origin should not be shaded, meaning we shade away from the origin, in other words, below this line. And so where they overlap would be what we consider our solution set. So that's where we kind of pour the paint on Alex. That's where we pour the paint. So see this green area is where you would pour your paint, right? Because that's where they overlap. Okay, so below this line and below the other line, meaning this green area is where you put your paint into. All right, number 11 says a store has 2 types of animal feed available. Type A contains 9 pounds of oats and 1 pound of corn per bag. Type B contains 2 pounds of oats and 5 pounds of corn per bag. A farmer wants to combine the 2 types so that the resulting mixture has at least 62 pounds of oats and at least 26 pounds of corn. The store has only 16 bags of type A feed, and 13 bags of type B feed in stock. Type A costs $2 per bag, and type B costs $3 per bag. How many bags of each type should the farmer buy to minimize the cost? So, first step is we find our optimization function. Okay, so we're trying to optimize the cost or minimize the cost, right? And so we say, okay, well, call it the C function. We're trying to minimize the cost of these bags. So let's see. Well, we know that type A. So let's call type A the X stuff. Okay, type A is the X stuff, and type B is the Y stuff. Okay, so Y equals. So no, type A costs $2 per bag, so I got it. So 2 X's and then type B costs $3 per bag, so plus 3 Ys. So we know at the end of this, we're going to try to optimize or minimize this cost function. Now we set up a table, not a chair. We set up a table here. Okay, so how we set up a table is first by saying, well, the type A stuff, we're going to put them all here. The X stuff, okay? And the type B stuff, we put them all here. That's the Y stuff, okay? And then this will be our totals at the end, okay? Then what other information do we have? Well, we know that type A costs 9 pounds, contains 9 pounds of oats, and 1 pound of corn. So let's say we call this the oats and corns area, right? So here's the oats, here's the corn. So let's put 9x here, and then 1 pound of corn, so 1x. Type B contains 2 pounds of oats and 5 pounds of corn. Let's call this 2x and then 5. Let's say 2y and 5y. So the formula wants to combine the two types so that the resulting mixture has at least, right? So that's a really greater than or equal to symbol, right? So at least 62 pounds of oats. So 9x plus 2y has to be greater than or equal to 62. And then at least 26 pounds of corn, right? So 1x plus 5y has to be greater than or equal to 26. But then we have a third inequality in here. Then we have some more inequalities in here. It says the store only has 16 bags of type A and 13 bags of type B, meaning X has to be less than or equal to 16, because that's a type A, and then Y has to be less than or equal to 13. So we have all this information that we're given here in this problem. Let's use the system of equations to solve it by graphing it. Let's use graphing to actually solve this system. So for the oats equation, okay, we got 9x plus 2y, we'll pretend it's an equal sign, equals 62. And so to graph that, we'd say, well, just find the x and y intercepts. The x-intercept would be plugging in 0 for y, so we get 9x equals 62, dividing by 9x equals 62 ninths, or actually about 6.9. To find the y-intercept, we plug in 0 for x, right? And so plugging in 0 for x, we get 2y equals 62, so y equals 31. And then we have to know where, so if I graph those, we'd say, okay, well, let's count by 5, so here's 0, okay, and we're in the first quadrant because we know we can't have negative bags, right? And so let's count by 5s here, so 5, 10, 15, 20, 25, 30, here's 35, way over here. Now my graph isn't to scale, okay? So the x-intercept would be here, right? And the y-intercept, 10, 15, 20, 25, 30, 35. The y-intercept would be here, got it. And so we put a line through them. Now we need to know if we're shading above this line or below this line. So how we find that out is by plugging in, say, a test point of the origin, right? So plugging 0, 0, we get 0 plus 0. Is that greater than 62? It's not. So we need to shade away from the origin, meaning we shade above this line. Then we get to the corn. Okay, so the corn, we say, well, pretend it's an equal sign. So x plus 5y equals 26. X-intercept, we plug in 0 for y, so we get x equals 26. Y-intercept, we plug in 0 for x, so we get 5y equals 26. So y equals 26 over 5, or 5.2. So then we plot those points, right? So x-intercept is 26, that would be here. The y-intercept is 5.2, which is down here. And so we draw a line through them. But now we need to test to see if we're shading above this line or below this line. So if we test 0, 0, we see that, okay, 0 plus 0 is not bigger than 26, so we know we shade away from the origin, in other words, above this line. And so we see where they overlap, which is this green portion, would be our solution set. And so now we want to find the critical points, or the border points of our solution set. So in other words, this point here, which we see is 0, 31. This point here, which we see is 26, 0. But we also need to find this point here, right, where they meet up. And so how we find where they meet up, we just use our calculator. And how do we do that? We'll use an augmented matrix. So augmented matrix called a matrix A would be 9, 2, 62, and 1, 5, 26. And again, we want to RREF this, right? Or RREF, row reduced echelon form. Again, RREF meaning the 1 to 2 R's, right? And so once we do that, we'll get 1, 0, 0, 1. So an identity matrix. And then whatever's on the other side of that augment will be where they meet up. So how we get to the matrix stuff, again, just like we did earlier, we say, well, second matrix or second X inverse. And then we go over to editing this first matrix. Now this one is a 2 by 3. And so now we type in the elements. So 9, then we get out of there second mode or second quits. Then we go back to the matrix stuff to find an RREF, right? So second matrix, and then go to math and go down to RREF, right? Again, the one with the 2 R's, okay? RREF, and then second matrix. Let's name that matrix, so matrix A. And press enter. We'll see we get that identity matrix, as well as that 6, 4 is where they meet up. So we found all the corner points of our solution set, but now our goal is to find which one of these optimizes, in this case minimizes, this cost function that we started with, right? So our cost function was 2x plus 3y, so which one gives me the minimum? And so first let's find C of 0, 31, right? That'd be 2 times 0 plus 3 times 31, which is 93. We find C of 6, 4. So that'd be 2 times 6 plus 3 times 4, which is just 24. And then we find C of 26, 0, which is 2 times 26 plus 3 times 0, which is 52. And so yes, C64 actually minimizes our solution set. But also, we didn't really have to check it. We should have known because we had some other inequalities that restricted us, right? We know that x had to be less than 16, the y to be less than 13. And so if that's the case, then we know it has to be below this line. The x has to be less than 16. And then below this line as well, the y has to be less than 13. So this actually would be our other corner points. But this is the one that minimizes it of all those solutions. All right, question 12 says, for the third week of October, Scott Washington worked 45.75 hours. Scott earned $8.70 an hour. His employer pays overtime for all hours worked in excess of 40 hours per week and pays 1.5 times the hourly rate for overtime hours. Calculate the following for the third week of October. Are your responses to the nearest cent if necessary, regular pay amount. So to find the regular pay amounts, we just say, okay, that's just the 40 hours times his regular hourly rate. So 40 times 8.70, and we get $348. To find the overtime pay, we say, well, he worked an extra 5.75 hours above the 40. So 5.75 times the 8.7. But again, he gets paid 1.5 times for overtime, so times 1.5, which gives us $75.04. And so to find the gross, we just say add these two, right? So 348 plus 75.04 gives 423.04. Our first one here says assume all interest is simple interest, right? So in addition to working and a family contribution, Jane had to borrow $6,000 over the course of 7 years to complete a degree. The interest was this amount, find the rates, right? Around 2 decimal places if necessary. So to do that, again, we have to do the simple interest formula. So that's I equals P. So that's I equals P times R times T. So we need to find the R, right? So here, the interest, it says it is 2986.20. The P is the principal amount, right? The starting amount. So that would be 6,000. Again, R is the one we're looking for. And T is the time in years, so 7. And so all we do is multiply 6,000 times 7 to give us 2986.20 equals 42,000 R, and then divide by 42,000. So R would equal 0.0711. And again, this is write it as a percentage. And so it's right as a percentage, we'd say just move decimal place 2 places over, right? And so that'll give us 7.11% is our rate. All right, question 14 says, in order to pay for college, the parents of a child invest $25,000 in a bond that pays 5% interest, compounded semi-annually. How much money will there be in 20 years? Rounding answer to the nearest cent. So for that one, we have to use a different formula, right? We know A equals, but we had 2 different formulas for compound interest. And so one of them was PERT, and the other one was called the other one. PERT we use if it said compounded continuously. This says compounded semi-annually, so we use the other one. So here we say A equals P times 1 plus R over N raised to the NT power. Now it goes to say how much money will be there in 20 years, meaning the future amount. So that's the A that we're looking for, is the future amount. So then P is still the principal amount, so 25,000 times 1 plus the R we have to write as a decimal. So if this says 5%, we know it's 0.05 over the N is how many compounds it is per year. So semi-annually would be twice a year. So N would be 2 raised to the 2 times, and then the T here is time in years, so 20. And so we just put this in our calculator. And so we get $67,126.60. All right, this one tells us to use PERT mainly because we see compounded continuously in this one, right? So to find the future value after 25 years of $4,000 of a $4,000 account that earns 4% interest compounded continuously, then compare the future value of the same account if the interest is compounded annually. Okay, so let's try it first. The first one says continuously, so we're going to use PERT. So the ending amounts we're looking for, the future value. The principal value of the principal amounts would be 4,000. E is just the number in your calculator. E is just E. Raised to the R, we say again as a decimal, 0.04, and then times T, which is 25. And so we put that in our calculator. And we get $10,873.13. Now if it was compounded annually, we use the other formula, right? So we got PERT, we got the other one. So the other one says 8 equals P times 1 plus R over N to the NT power. Okay, we're still looking for the future value, the A, the accrued amount. So P here would be 4,000 times 1 plus R is 0.04 still. The N this time, N is the number of compounds per year. So it says compounded annually, N is just one time per year. raised to the 1 times, and then T is the time in years, so 25. So putting that in our calculator, we get $10,663.35. And so we're saying which one earns more. So it says the account earns how much more of an interest is compounded continuously. So we know it's more, and then we just subtract those numbers, so we get $209.78. All right, this one says Jason's Nana gives him a check for $300 on every birthday. He deposits these checks into an account that pay 5.7% interest compounded annually. How much will be in the account after 17 years? So for this one, we use the TVM Solver in our calculator because we're doing periodic payments because Jason's Nana is giving him money every year in this account. So to get to the TVM Solver, we press apps, and then it's finance is the first option. And then TVM Solver is there. So apps, enter. So now we get to filling in. Now, we need to know which one we're looking for, right? So notice in our TVM Solver, we got we got to fill in. We got I%, we got to fill in. Then we got present value, PMT, future value, and then PY is payments per year, and CY, which is compounds per year. So which one are we looking for? Where it says how much will be in the account after 17 years, right? So know either PV or FV, one of them is 0. If it's a savings account, then the PV is 0. If it's a loan, then the FV is 0 because you want to owe nothing at the end of the loan, right? So here, since this is a savings account, then this PV is going to be 0 here, okay? Now, FV says how much will be in the account after 17 years. That's the one we're looking for. So then we have to fill in the rest. So N is the number of payments we're making total. How many payments we're making over this amount of time, right? So it says Jason's Nana gives him a check on every birthday. He deposits these checks into the account. How much will be there in 17 years? So this is just 17 payments. I% is 5.7%. Again, it says I%, meaning leave it as the percent. Then the PMT would be the amount of payments every time we put some money in the account. So it's $300. So we'd say 300, but when you put the PMT in your calculator, you have to put a negative of whatever it is, okay? Because it's coming out of some account. So always put the negative for the PMT. And then payments per year, compounds per year. Since it's annually, it says compounded annually, and we're only paying it once a year into this account, then PY and CY are both going to be 1. So putting that into your calculator. When we get to FV, we're going to skip it. Whatever's there, just skip it, okay? We'll come back to it. Payments per year, compounds per year are both 1. And then for PMT at the end, make sure that end is highlighted, okay? Then we go back to FV, the one we're looking for, and we need to solve for this one. So look right above the enter button is solve, right? So there's the green, so we know we press alpha enter. So have FV highlighted, press alpha enter, and now it tells us the amount that would be there in the future. So here we got 8242.67. I know, 67. So 8242.67. But then the second part of it says how much of the balance is from interest. So how we find that is by noting, okay, I'm paying $300 every year. So that's the amount that should be in the account over those 17 years, 300 times 17. Or in other words, to find the interest that is accrued over this time, we'd say, well, the ending amount that I ended up with, so FV, but then minus the N times PMT, right? So N times PMT, because that's how much money should be in the account. So here we get 8242.67 minus 17 times the 300 that should be in the account, which would give us 3142.67. All right, we're almost done. So here 17 says an online leading service recently offered 48-month auto loans at 3.4% compounded monthly to applicants with good credit ratings. If you can afford monthly payments of $329, how much can you borrow? So again, this is a loan and it's monthly payments, right? So we know we use the TVM Solver. So we got to fill in, okay, N, I%, PV, PMT, FV, payments per year, and compounds per year. Now again, either PV or FV is 0 depending on if it's a loan or a savings account. So this is a loan, we know the FV is 0, meaning we want to owe nothing by the end of the loan. So let's fill in the rest, okay. It says you're offered 48-month auto loans, meaning if we're paying monthly, then N is just 48. I% would be 3.4%. We know we're paying monthly. It says if you can afford monthly payments of $329. So that's the PMT. Again, make sure we put a negative sign there. And so the present value is actually what we're looking for because it says how much can you borrow right now, right? That's what we're looking for. And then the payments per year, compounds per year, again, is 12. It says compounded monthly and we're paying monthly. So both of those are 12. So we fill it in on our calculator. Again, how we get there is apps, enter, right? Apps, finance, and then TVM Solver. N is 48, okay. I% is 3.4. Present value is what we're looking for, so skip it. PMT we know is negative 329. FV is 0. We want to owe nothing by the end of the loan. Payments per year, compounding these per year is 12 each. And then PMT at the end, make sure the end part is highlighted. Then we go back to PV, the one we're looking for, and we just press alpha enter, right? Again, solve is right there, so alpha enter. And so that's how much we can borrow right now is $14,745.72 or $14,745.72. But then the second part says, what is the total interest you will pay? So this is a loan. We know, well, I'm paying 48 times. I'm paying $329 each. But I'm actually paying more than that because some of that is an interest. But we know some of that is an interest. And so we actually say, well, to find the interest, it's actually N times PMT minus how much I'm actually borrowing. So minus the present value. So that'd be 48 times 329 minus 14,745.72, which gives us 1046.28. This says a house sells for $240,000 and a 5% down payment is made. A mortgage is secured at 6.2% for 30 years. How much money is borrowed from the bank? So a mortgage essentially is a loan, okay? So we have to keep that in mind, and you pay monthly on your mortgage. So because we know this is a mortgage and because we know this is a monthly payment, we know this is a TVM solver problem. So to find out how much is borrowed from the bank, the first part is to say, well, if I'm paying 5% down payment, that's how much I'm paying straight up front, okay? And so the rest of it is how much would be the loan or how much I'm borrowing from the bank. So if 5% is the down payment, there's 95% of that I'm borrowing. I mean, to find how much I'm borrowing, we say, well, 0.95 times 240,000, which would be 228,000. So then to find the monthly payment on the mortgage, we use our TVM solver. So let's fill it in. Okay, NI percent, PV, PMT, FV, payments per year, and compounds per year. Again, since it's a loan, we know either PV or FV is 0. This time the FV is 0 because it's a loan. We want to owe nothing by the end of the loan. So let's fill in the rest. Okay, N would be how much I'm paying. N would be the number of payments I'm making, right? So it says 30 years, and we know we're paying monthly. So 30 times 12. I percent, it says 6.2% is the month. It says 6.2%, so that would be our I percent here. The present value is how much I'm borrowing in this loan, which we just said from the previous part is 228,000. The PMT is what I'm looking for. It says, what is your monthly mortgage? So that's the one I'm looking for. Let's skip it. And then payments per year, compounds per year, we're paying monthly. So 12 and 12. Again, how do we get there in our calculator? We press apps, then finance, and then TVM solver. Apps, enter. Then we fill in. Okay, so 30 times 12 would be our number. 30 times 12 would be the number of payments we're making. I percent, we said 6.2. P, present value is 228,000. Okay. PMT is the one we're looking for, so just skip it. Future value is 0 because we owe nothing by the end of the loan, and then payments per year, compounds per year, both 12. Again, make sure this PMT down at the end is highlighted as end. Then we go back to the one we skipped, so back to PMT, and to solve for it, look right above the enter button is solve, right? So we press alpha, enter to solve. And so our monthly payments would be $1,396.43. But then it says how much interest is paid on the loan. So again, to find that, we know, well, we're only borrowing $228,000, but we're paying 360 times, and we're paying $1,396.43 each time. And so to find out how much is interest, we'd say, well, N times PMT, but then minus the amount I'm borrowing, the PV. So here that'd be 360 times 1396.43 minus the 228,000. This one says round to nearest dollar, so we'd say 2747.15. In other words, $274,000 in just interest. 19 says a grocery store employs cashiers, stock clerks, and deli personnel. This one says a grocery store employs cashiers, stock clerks, and deli personnel. The distribution of employees according to marital status is shown next. Okay, so if an employee is selected at random, find these probabilities expressed as reduced fractions. So this one, the employee is a cashier or is not married. So when we have stuff like this, we probably should find the totals as well. Okay, so the total here is 132 are married and 108 are not. So out of that, so there's a total of 240 employees. Also, we find these totals as well, right? So there's 90 cashiers total. There's 121 total stock clerks. And there's 29 total deli personnel, which still is 240 total employees. So again, we're trying to find a probability. The probability that the employee is a cashier or is not married. So that word or is critical, right? So probability that's cashier or not married. We have to consider, can they overlap? Are there cashiers that are not married? There are. There's 36 of them. So we'd say, well, find the probability of a cashier plus the probability of not married minus where they overlap. Probability of cashier as well as not married. So probability of cashier. There's 90 cashiers out of a total 240. Plus, there's 108 total not married out of 240. But now we have to subtract the ones that are both because they're counted twice. So minus 36 out of the 240, which gives us 162 out of the 240. Or as a reduced fraction is 27 out of 40. Part 2 says find the probability that an employee is not married. The probability of not married is just 108 out of the 240, which reduces just 9 out of 20. Part C says find the probability of the employee is a stock clerk or married. The probability of stock clerk or married, where we say, well, are there ones that are both? There are. There's 67 of them. So we'd say, okay, that's the probability of stock clerk plus the probability of married minus the probability of stock clerk and married. The probability of stock clerk is 121 out of the 240 plus probability of married is 132 out of the 240 minus the ones that are both because they're counted twice. So that's minus 67 out of the 240, which gives us 186 out of the 240, which reduces to 31 out of 40. All right, this one here says we have a deck of 8 cards numbered from 1 to 8. Some are white and some are gray, as shown below. Okay, the cards numbered 1, 2, 4, 5, 6, 7, 8 are white. The card number 3 is gray. Answer the following questions. Write each answer as a fraction. A card will be drawn at random. So what's the probability that the number 4 card is drawn? Got it. Well, there's only one number 4, so 1 out of 8. Easy stuff. Part B says, what's the probability that number 4 card is drawn, given that the card drawn is white? So again, when we see that word given, we want to start with the given is the phrase, right? Start with your given. So we start with the given, meaning it says given that the card is white. There's only 7 of them that are white. So that's our new denominator. And then of those, how many have a number 4 in it? Just 1. So now it's 1 out of 7. All right, this one says an automobile manufacturing plant produced 32 vehicles today. 16 were trucks, 7 were sedans, and 9 were vans. Each vehicle falls into one of these categories, okay? Plant manager is going to select 2 of these vehicles for a thorough inspection. The first vehicle will be selected at random, and then the second vehicle will be selected at random from the remaining vehicles. Got it. What's the probability that the first vehicle selected is a truck and the second vehicle selected is a sedan? Now, again, this is without replacement. So kind of when we do these slots that we have here, we're not replacing that vehicle because it says the second one is picked from the remaining. Right, so it's not replaced. And so let's just set up what's the probability. So what's the probability that the first vehicle is a truck? There's 16 trucks out of the total 32 vehicles. Okay. And then we'd say, well, how many vehicles are left? There's 31 left. So of the 31 that are left, how many are sedans? Well, there's 7 sedans. And so what do we do with these? Again, by our fundamental accounting principle, we just multiply these numbers. So 16 times 7, we get 112. 32 times 31. 32 times 31, we get 992. So we just multiply straight ahead. And it says final answer to 3 decimal places. So putting this in our calculator, we get 0.113. All right, this one says, over the past several months, customers at Stymie's department store has been asked to fill out customer satisfaction surveys. In the surveys, the customers rate their shopping experience on a scale from 0 to 100. Here are 10 recent ratings. What's the mean of this data set? To find the mean, that's the average. So that's X bar that we're looking for. And again, we can use our calculator to do so. So first, we put these numbers in a list by pressing Stat and then Edit. If you have numbers in here, you can delete those numbers in the list one by one or use the Clear List option. So then we type in our numbers into this list. Then we press Stats and we want to go to Calc. And one var stats is where we're kind of headed towards. So go to one var stats. Sometimes this option comes up if you have this calculator. If it doesn't, just press second 1, which gives us the L1, okay? But if it doesn't come up, but if it does come up, you can just type in list 1. Under frequency list, don't put anything, and then just press calculate. And so the X bar here is 56.3, which would be our mean. Then to find the median, says what's the median of the data set? It's in that same list. We just have to scroll down. So if we go down, we see MED, that's the median. That's the median, which is 56 here. And then it says how many modes does this data set have? What are their values? Indicate the number of modes by selecting the appropriate line, and then indicate the value for that mode. So mode is just the most frequent data point. Now, your calculator doesn't do that part because it's pretty easy to find. So we just look and see which one occurs the most. Here, 56 occurs twice, but so does 58 occur twice. So we just say there's 2 modes. There'd be 2 modes, 56 and 58. So we don't take their average, we just say both of them are the mode. All right, this one says each member of the football team was asked to report the year he was born. Which measure gives the most common year of birth? Again, most common, most frequent would be the mode. Jenny has recorded the number of miles she has driven for each of the last 9 weeks. Which measure should be used to summarize the data? So again, anytime they have an outlier, we don't want to really use the mean. And so since this one has an outlier of 782, we actually want to use the median instead. Whereas this one here, in the past 10 days, Gina has received the following number of email advertisements per day. Which measure should be used to summarize the data? Again, since there's no outliers here, these numbers are kind of gathered together, are kind of close together, then we use the mean here. All right, last 2, hang in there. So 15 students were selected and asked how many hours each studied for the final exam and statistics. Their answers are recorded here. Find the range, variance, and standard deviation. Okay, so how we find the range? Remember, the range is just the highest minus the lowest. So here that'd be 10 minus 0, which is just 10. But to find the variance and standard deviation, well, first we'll go to standard deviation. So we're looking for in our calculator S sub x, okay? So how we get there is first by putting this list in our list, in our calculator. Again, to get to list, we press stats and then go to edit. I have numbers in my list, so I'll just delete them one by one, okay? There is a clear list option, but this is pretty easy. Let's just delete them one by one. So then let's type these numbers in our list. Then we go to stats, and we go to calc, and one of our stats is what we're looking for. Again, if this option comes up, just leave it as list one, and then frequency list, don't put anything. If this doesn't come up, just press second, the number 1 on your calculator. Now again, we're looking for that S sub x. So here 3.49 would be our standard deviation. This is the sample standard deviation. Then to find the variance, we could type those numbers in and just square it. Remember, the variance is S sub x squared, okay? Or instead of typing those numbers one by one, we can actually find that variable and square it. So how we find the variable is by pressing vars here. And then this is a statistical variable, right? So we're going to go to statistics, number 5. And then there's the variable right there, number 3, the S sub x. So we're going to press enter on that S sub x and then just square it, right? There's a squared button here. Press enter and now we get our variance. So it says around to 1 decimal place, so 12.2. All right, last one. So below are numbers of hours that a sample of 18 college graduates reported working last week. Construct a box and whisker plot. How we find that is by first finding the 5-number summary using our calculator. So to find the 5-number summary, press stats, go to edit, and put these numbers in a list. Now again, I have numbers in my list 1, so I'll just delete them one by one. Or you can use the clear list option. And then we type in our numbers. Then to find the final summary, press stats, go to calc, and it's under 1 var stats, which is 1 variable statistics. If this comes up, then you just leave it as list 1, and then frequency list, don't put anything. If it doesn't come up, press second 1. That'll bring up list 1. When I press enter to find a 5-number summary, we go down, we scroll down. And the last 5 numbers they have there, the minimum, Q1, the median, Q3, and the max, those are our 5 numbers. So to get the box for the box and whisper, we first start off with the median. We put a vertical bar at the median, so 54 here. And then our box is boxed around Q1 and Q3. So Q1 here is 48, we put a vertical bar there. And then Q3 is 60, so we put a vertical bar there. Now we put a box around those numbers. Now whiskers just go to the max and min. So here the max is at 70 and the min is at 39. Now those whiskers extend to the box. And though I know my graph looks superb, here's a better one. Always remember, math is everywhere.